Hi y'all, in this video we're actually going to be looking at two things today. First, the easiest thing in the world is just how to tell if you've got proportional ratios. I'm going to describe what that means in a second. And then after that, I'm going to show you guys how to solve a proportion. Now, before I even talk about what a proportion is, I just actually want to remind you guys about ratios, and that was from our last class. Let's talk about one ratio and then how it might be something that's actually considered a proportion. So if I were to ask you guys here looking at this, what is the ratio of my dot to triangle, my circle to triangle? You guys would tell me that the ratio is 1 to 2. And in the last class, we talked about a couple of different ways that you might write that. And I'm going to focus on the last format here, the ratio as a fraction, where we're comparing the circle here to the two triangles, and that's a 1 to 2. Now, when we say that something is growing proportionally, and the word that I'm saying is this, proportionally, what we're saying is that if I'm going to increase the number of circles, I should increase the number of triangles proportionally. If I get one more circle, then I should have 2 more triangles. If I'm going to add another circle to that, then I need to add 2 more triangles. So what we're saying, y'all, is that, whoops, sorry about that. Let me get my pen out. If we now see 3 of these circles, how many triangles do we count? 1, 2, 3, 4, 5, 6. And what we have now created, y'all, is something called a proportion, which is this thing right here, showing me 2 equal ratios. If I were to add in another group of this, then I'm saying, okay, my initial ratio, I'll put it back in blue, the original ratio was a 1 to 2. And now I count 4 of these, so I should count 8 of these, and I do, and that's proportional. Okay? Now something that's not proportional would be if I have 4 of these and I throw in another one of these. Well, now my original number would have been the 1/2. I'm going to put it up here now. I would have said the original ratio was 1 to 2. And now I'm counting 4 of these and 9 of these. And you guys can see here that 1/2 does not equal 4/9. It actually does not equal 4/9. So this would be not proportional in this situation. It did not grow proportionally. All right, so now back over into the notes, kind of let's formalize this, all right? So again, a proportion is when 2 of the ratios are equal. And the ratio here is just basically one of these fractions. So we've got a couple ways to prove that fractions are equal. And the easiest one is going to be to reduce. And I'm going to just write that off to the side here. Reducing is something that a lot of you guys know how to do from elementary school. But it's something that we don't really like doing. So I do have a backup method in case you don't like reducing. But again, it is really easy to see here that 15 divided by 5 is a 3, and 25 divided by 5 is a 5. So I know that these two ratios, the 15/25 and the 3/5, those two ratios are equal. Therefore, this is a proportion. Now again, reducing is not everybody's strong suit. Not everybody in here likes reducing. So I actually have a quicker, shorter, better method. And it's simply to cross multiply. Most of you know that 25 times 3 is a 75. And then over here, if I do 15 times 5, it's okay if you don't remember that in the calculator. I can show y'all real quick that 15 times 5, there it is, it's a 75. So here when we cross multiply, since we get the same answer, then yes, this is proportional. All right? Now for the next one, again, you could reduce or just say, okay, I know that 80 times 1 is 80, and 20 times 4 is also an 80. So I know that this is proportional. So if you cross multiply and you get the same answer, then yes, it's going to be proportional. Let's try another one here. If you don't remember that 8 times 30 is 240, it's okay to just see it. You can just take your calculator and do 8 times 30. Okay, good. I got a 240. So 8 times 30 is 240. And then 5 times 48, I bet nobody in here knows that one off the top of their head. So we'll see that one in the calculator. We got a 5 times 48. All right, cool, so it's a 240. So again, because I cross multiply and get the same answer, these are proportional, okay? So again, the thing I'm gonna mention is cross multiply. you want to cross multiply. I would write that down in your notes, just so that you know that cross multiplying is kind of the main strategy here. Now, if we cross multiply here, you'll see that the answers are not going to be equal, and that's what that symbol right there means. That means not equal. So if we do 12 times 5, most of you remember that that's a 60. It's okay to use a calculator if you need to. And then when you do a 10 times 7, we get a 70. So that's not proportional, okay? If you take the 10 and cut it in half, you get a 5. If you take the 12 and cut it in half, that should be a 6. So that number right there is not the right number. All right here, y'all know that if you do 2 times 3, that's a 6. And 1 times 10 is 10, and that is not proportional. They're not equal, so they're not proportional. And last but not least over here, if we do a 6 times 3, that'd be 18. And so since it's 6 times 30, I just get to tack on a 0. And then 30 times 50, you guys know, is a 150. So again, not equal, so these are not proportional. Now, we've seen this on a lot of the state testing. They'll just give a bunch of these types of numbers and say, okay, I want you to identify which of the following ratios are proportional and which are not. So remember, I'm going to highlight here just so it stands out. Let me get a highlighter out here. In blue, this is a ratio. That thing is a ratio. We got 9 compared to 27. And we want to see if proportionally it would be the same as comparing a 3 to an 8. So again, one of these by itself is a ratio, and then together, if they're equal, it's a proportion. So let's find out with this one here. If we cross multiply, a 9 times 8 is 72. And let's see what happens in the calculator if we do a 3 times 27. So 3 times 27 is an 81. We got an 81 for that one, and a 9 times 8 was a 72. So these here are not equal. So we are not, that is a which is not. This one is not proportional, okay? All right, now let's take a look at the next one. Now a shortcut that some of you might already be seeing here, I know you're like, okay, that's a 30 and that's a 30. So I'm going to say yes to this one. This is definitely a yes. This is proportional. But some of you might have caught that if you do 3 times 5, you get 15. And 2 times 5 is also a 10. So it is okay here to catch that you're just simply multiplying by 5. When you guys realize that, that's actually something called a scale factor. And I'm going to define that down below at the bottom of the page. So it is okay to do this. If you catch a scale factor, that's okay. Let me go back to this first one. The scale factor here, you would have to divide this thing by 3. But if you do 27 divided by 3, you're expecting this number here to be a 9. So since that's not the right thing, that's again a not proportion. Here everything lines up, so this one is a yes. All right, let's look at the next one. So some of you are instantly seeing that scale factor thing where you're like, oh, okay, if I just divide this thing by 3, or if I divide this by 3, and when I divide by 3, I get a 2, and here 27 divided by 3 is 9, so yes. Everything here is proportional. Now the cross multiplying thing that I showed you guys, let's just see that in the calculator lightning fast. If we do 6 times this 9, most of you remember that that's a 54. And if we do 27 times 2, that's also a 54. So since we get the same answer, 54 equals 54, we know that this right here is a proportion. Now with this one, I don't think y'all's math is good enough in your brains to identify a scale factor. For this one, I would probably just go straight to the calculator. All right, so we've got a 12 times 65, 12 times 65, and that's going to be a 780. So 780 is one of the numbers, okay? Now let's do the other number. It would be a 60 times 13, so 60 times 13. And we get a 780. And since we got the same answer both times when we cross multiplied, then yes, these are proportional. Again, when you do 12 times 65 and 60 times 13, oh my gosh, I can't talk now. 60 times 13, we get the same answer. All right, so we've got one more to just try here. So let's bust out that calculator. A 12 times a 6, I'm going to do 12 times 6 first. I get 72. So we did 12 times 6. And now let's do 13 times 5. Most of y'all know that your 5s are going to end in a 0 or a 5, so you're like, it's not going to work, but we'll try to see it in the calculator anyways. Whoops. There's the, 13 times 5. There it is, 65. So since 13 times 5 is a different answer, cancel out. Nope, this one is not proportional. Not proportional. So when we look back at this and kind of finalize our answer here in yellow, we can see that this, and this are proportional, while this one is not, and this one was not proportional. Okay? So that's all you've got to do for this first thing for today to identify if things are proportional or not. You literally just cross multiply. You literally just cross multiply. And if they're equal, the answer is yes. If they're not equal, the answer is no. All right, so then down here, do you guys notice that this time there is a missing number in every problem? And what we want to do is figure out what number has to go in this missing spot so that it is a proportion, okay? Now you guys have done something like this before. For example, if you see a 1 over a 2, and then over here you see a 10, if you can tell me what number goes right there, you're good to go. 10 is half of, and then this would be a 20, okay? So you can tell me a missing number. Let's try another one. What if you saw a 4 out of 5? And this turned into a 12. I want to know what this would be. Well, this one is 3 times bigger. So this should be 3 times bigger, which makes this a 15. That would be a 15. Okay? So what we're going to do right now is practice how to find a missing number. And that missing number could be in any one of these spots. And so that's why I've got 4 different examples that I'm going to walk you through right now. So we don't know what number goes here, but I do know that it's supposed to equal whatever 2 times 45 is. You might remember from up above, we literally just cross multiplied. And so if we can see in a calculator what 2 times 45 is, then I know what this has to also equal. So first I'm going to do 2 times 45 in my calculator. Okay, so 2 times 45. So I know it's got to equal a 90. So this other thing, 9 times some number has to equal a 90. Now most of y'all know that that's a 10. So in your brains, you're like, okay, it's got to be a 10. So I want to show you guys that all you got to do is cross multiply and then divide by the other number, and that's it. I'm going to show you one more time how to do this. You cross multiply, so 2 times 45. You multiply the numbers that are there, then divide by the one that's with the letter. So x here would be a 10. Okay? So all I did first was 2 times 45, and I got a 90. And I know that that's supposed to equal whatever 9 times my unknown is. So in the calculator, we just divided by a 9, and that allowed me to see 90 divided by 9 was a 10. And this is actually how we show the work here in blue. This is how it looks in the language of algebra. You're showing me that it should be a 90, and that 9 times x should equal it, kind of like up here, proportional. They should equal each other. And then you're just showing me here dividing by 9 with a fraction bar. And anything divided by itself cancels out. So on this side, I'm left with x, and over here is the answer 10. So again, that right there is how you show your work in the language of algebra. Okay? So now let's try this one. Do you guys see that the numbers we have to cross multiply are a 10 and a 2.5? So let's cross multiply that now. We've got a 10 times a 2.5. So I get a 25. So I know it's supposed to equal a 25. Now I've got 5 times some number. It's supposed to equal 25. Now most of you guys already know this, that the answer is going to be 5, because when you do 25 divided by 5, you do get a 5. Okay? So again, to see it in the calculator, I now simply divide by the one with the letter, and there's the answer, 5. Now before I show any work, I'm just going to show you guys here the process. We're going to do a 4 times a 17 in the calculator. So 4 times 17 is a 68. Now I'm going to divide that by this -2. And see how I typed in the 2 and then made it negative? So the answer here is a -34. I'm going to model this one more time in the calculator so that you guys can see that. I simply did 4 times 17. Now I'm going to divide by the -2, so divide by a 2 and make it negative. So my answer here is a -34. All right, so again, to show the work, in the language of algebra, that should have been a 68. And I know that it's the same as -2 times some number. So I'm going to divide by the -2. Anything divided by itself is gone. So in the language of algebra, I'm proving what x equals. And over here, we just used the calculator to prove that it was a -34. And now here for this last one, you guys know that 8 times 3 is a 24. So my other side has to equal a 24. And it's 12 times some number. Most of you are going to already see that it's going to be a 2. 12 times 2 is our answer. But to prove it, I'll just divide, and right there, 24 divided by 12 is a 2. And I'll show you one more time in the calculator so you can see how lightning fast this is. You've got 8 times 3. 8 times 3 equals, and then you divide by the other number, so there's the 12, and that's how I got my answer is 2. So what you guys see me doing here is the first answer. When solving a proportion, I can cross multiply. We just solved the proportion to figure out what the number had to be so that they were equal. I'm actually going to erase everything now and show you something that it'll only work sometimes. It's kind of a shortcut. It won't work for everybody depending on your math skills, like your memory math. But like a lot of you see for this last one, for example, let me focus on this last one. A lot of you see that for the bottom, it got 4 times bigger. So you're like, okay, 3 times 4 gave me this 12. So then what times 4 would give me this 8? And automatically you can now tell me that this has to be a 2. Because again, we're just simply multiplying by 4. So if you can identify that thing, it's called a scale factor, that works. That is a good thing to be able to do and say, okay, so this has to be a 2. Let's find another scale factor. So like right here, I see 5 times 2 gives me 10. So I'm just going to do times 2. And if I do times 2, I get this answer right here, and you'll see it's the same as what we already found. Here's another one. I can do 9 times 5. See, not everybody's going to remember 9 times 5 gives you 45. But if you do, you can then say, okay, so 2 times 5 would be what? And this one right here has to be a 10. So that's what the deal is here with a scale factor. Okay, the scale factor right here, a lot of you saw it, times 10 times 10. So right here, when you see times 3, you can do times 3. So it's okay to see the scale factor like that. In fact, let me show you another way you could see scale factor. What if you saw a 1/4, and then right here you saw a 5 and an unknown? Well, what do you got to do to 1 to get 4? So times 4. So you could do times 4 right there and make it a 20. So the scale factor thing is a shortcut that a lot of you can see and use. But if you're ever unsure, you can just cross multiply and say, okay, so 5 times 4 is 20. So then 1 times what? Oh, 20. Okay. So that concludes our video here for how to solve a proportion. You just cross multiply in the calculator and then divide by the other number that's across from the x there. And that will work every time. And then also we talked about how to identify your proportional ratios. Thank you for watching.